Today I'm going to talk to you guys about the difference between a empirical formula and a molecular formula. So I'm going to try not to overteach this because the difference is pretty straightforward. Here we go. Okay, so an empirical formula, think about it just like pretty much anything. Um, there are a bit of specifics, but let's just start with something simple. Like an empirical formula could be something like CO2. Okay, I'll just make this into a little T-chart here. Now, a molecular formula, the first thing you need to know is that there's a bunch of different possible molecular formulas. One example of a molecular formula would be something like C2O4. Another example would be something like C4O8. What I hope that you guys notice for both of these formulas is I pretty much just took CO2 over here, and in the first case here, I doubled it. I kind of, instead of having, one C and two O's, I have two C's and four O's. And in the second case here, I kind of multiplied it by 4. That's pretty much what a molecular formula is you just take whatever your empirical formula is. So your EF just kind of equals whatever your EF is. But then your molecular formula is just kind of the same thing as your empirical formula multiplied by some number, which I'm represented by X here. So, it could be 2, it could be 4, it could be, 1,000 or whatever. Doesn't really matter. You just have to multiply it by some. Let's be a little bit clear here. The number should be a whole number. So hopefully that makes sense. Okay, now there are some things that could not be a empirical formula. For example, something like C2H2 is not an empirical formula, right? The empirical formula would be CH. Or something like, C4H10. Again, that's not an empirical formula because the empirical formula would be C2H5, right? So kind of the idea is you should have at least one odd number in your empirical formula in order to kind of make it work. I guess, though, that's not always true. For example, you could have, C3H9. The bottom line is there should be, think of it like a fraction. There should always be a way to kind of simplify it so that you couldn't, make it any smaller, for example. There's no common denominator other than 1. So yeah, that's empirical formula versus molecular formula in a nutshell. How we would make this complicated, right? Not that you necessarily should, or not that you necessarily could, but we could say something like, okay, H2O, as of course we all know, has a molar mass of 18.02. And then maybe the question could be something like, what would a molecular formula, what would its molar mass be? And it could be like a, I don't know, we have like 38.04, B, we have 36.04, C, we have 24.02, and D, we have, I don't know, 18.02, right? In this case, the obvious answer is if you multiply this by 2, okay, now I'm having to just double check my math here. I think you get 36, right? Yeah, 0.04. So the answer here would be B, just because all these other ones are not your, molar mass multiplied by an exact number. So in this case, the formula would be, H4O2, for example, and that's a molecular formula versus this is not, and these other ones also are not. So yeah, we could ask you questions again with molar mass, asking you to multiply it in the same way that you kind of, for a molecular formula, you take an empirical formula and then you multiply it by some number. We could also ask you kind of, the same question except flipped, being like, you have some molecular formula, it's got some molar mass, What are your guesses as to what the empirical formula is for this? Something along those lines. Okay. Oh, I don't know what just stopped working. I hope this makes sense. Anyways, and I hope you guys have a great rest of your day. We'll see you next time. Take care.